We're into lesson 8-2. With Miss Wheeler, you had done lesson 8-1 on translations, which should be glued in from yesterday on pages 72 and 73. And today we're going to be moving to page 75. So please make sure that you're skipping the left page, which is an even page, and going to page 75. And this one today is a second transformation, which is called reflections. And very similar to when we talk about reflecting something, it's flipping it around like you would see when you look in a mirror. It is a flipped image of you. And so we'll be reflecting on graph paper objects about different lines. And so the transformation you did yesterday was a translation, also referred to, and I'm just going to put this in my header here at front, as a slide or a pushing movement. Reflection is just what it says. It's reflecting. It's going to be flipping over onto a different side. It's going to look a little different, the orientation. My best thought when I was working with 5th and 6th graders on this is thinking about a butterfly and how the wings, when they fold close, they mirror image, or like your hands, when you put your hands together, they reflect, they flip about. So when those butterfly wings open, they're so pretty and they're so beautiful, but they're mirrored images of each other. Okay, and so we're going to be pushing on over to page 75. So if you'll flip that over, and you'll be want to make sure you glue in your little sheet today, and it's just going on that right side, not on the left side. So we're going to be talking today about reflections. And again, a reflection is a flip, or to flip an object, to flip it around. And so we're going to write here the word reflection. Reflection. To flip, or a mirror image of the original figure. That figure is going to stay the same size and shape, just like it did with the translation. But we're going to be flipping it along a line of reflections. So that line, whatever line I've drawn for you, is going to be about which you're going to flip the object. So this is called a line of reflection. And we're going to be drawing those lines of reflection. And it's the line over which the transformation of a figure occurs. And this typically for your STAR test and for purposes this year, we're only going to be practicing a line of reflection over the x-axis itself or the y-axis itself. You can have other lines of reflection, other lines that aren't necessarily the axis itself, the axes themselves, but we're not going to get into that. So just a reminder, your x-axis is the axis that travels from left to right. When you're plotting points, that's where you start. And your y-axis is the axis which is running up and down. So if I tell you, here's a rule with x and y, and this is called an algebraic representation, also referred to as the rule for the transformation. If you notice that the x is staying the same, and the y has flipped to an opposite value. And we've talked about opposites last year and this year. That means that if I had 4 here, it would be -4. 4 and -4 are opposites because they're same distance from 0 on a number line. So -4 and 4 are opposites. So if I want to reflect an object over the x-axis, here's what's going to have happen. And if you notice, the x values stayed the same. When you flip about a y-axis, the representation, or the algebraic rule, will show that the y's stayed the same. And so we're going to prove why that happens. So we're going to take a look at these 3 points and we're going to graph them. So we're going to graph the point -1, 2. So I start with my pen or my pencil at 0, 0. I travel 1 to the left and up 2, and you're going to plot your point there. Point B is located at -3, 2. So -1, 2, 3, +2. And then I want you to take a ruler, and you should have a ruler with you if you don't use some kind of straight edge, and we're going to connect those 2 points together. Okay, so this is point A, this is point B, and then point C is located at -3, +5. Okay, so -3, +5. And we're going to go ahead and we're going to play connect the dots with our points. And it's going to look like so. Okay, so I have my triangle. Now I knew it was a triangle because I had 3 points. If I had 4 points, it'd be a quadrilateral, 5 points, a pentagon, and so on. So now we're going to find where it moves to. Yeah, yesterday you did translations. Each of the points slid the same direction, the same number of spaces. A reflection is different because we're going to flip the object over. Some points are going to change a little bit. And we're going to flip, it says, along the x-axis. So I want you to take probably a pencil or something light at this point, and we're going to shade the x-axis. So I'm going to take my ruler here, and this is the x-axis, and I am just going to, I want to darken it a little bit, some shading on it so that I can see that that's my x-axis. Okay, so I'm going to make this a little bit darker. Okay, so I'm flipping or reflecting along the x-axis. Okay, so that's going to be my line of reflection about which I'm going to flip the object. Okay, so the easiest way to do this, and when you're on the STAR test and all they do is give you points and you don't have a graph, you get grid paper on the STAR test. Pull that grid paper out and by golly, plot those points. And so I'm going to move each of these points and I'm going to reflect it. So just like butterfly wings, this object is going to flip over here. Okay, so butterfly wings or hands, when they reflect, they go together like this and then they open up. So this point A is located 1, 2 up from the x-axis. So I'm going to go 1, 2 down from the x-axis. So if you notice, they're traveling the same distance, just reflecting around that line. So you can see if I take this and flip it over, it's going to go over here. 2 distance up from B, so I'm going to go 2 distance down from the line, from that line of reflection. So this will be called A prime, and this will be called B prime. And prime just means that I've actually moved the point. It's made a change. So we call it prime. It's just what it is. Okay, now this point here, if you notice, I'm going to flip it over the line. It's going to go down here. So if I count I count from the line of reflection, 1, 2, 3, 4, 5 squares. I'm going to go down 5. And reminder that this is 1 here. 1, 2, 3, 4, 5, because those numbers are written on the line. And this will be C prime. And then what I do is I want to connect my dots. I'd use your straight edge, okay? And then I have my reflection. Now, if you're having a hard time seeing it, I always suggest sometimes, and even on the STAR test, that you physically turn the page and you can actually see, it looks like the body of a butterfly here, the 2 wings here, and then when they fold up, they're going to match. Now, they're not hitting exactly on that line of reflection, but you can see that it actually has flipped over. All right. So now to the points. How did they change? Well, A prime is located at -1, -2. So if you take a look, you can notice what happened. The x's stayed the same and the y's went to the opposite value. So the 2 went to a -2. This is why we said it's over the x-axis. It's the x's that stay the same. It's the y's that change or flip. So the y's are flipping. On B prime is located at -3, -2. So the x's stayed the same. The y's switched to the opposite value. C prime is located at -3, -5. And again, the x's stayed the same and the y values flipped. Therefore, I mean, you can kind of tell pretty easily the changes that are being made. All right, let's move over to what happens when I want to reflect around the y-axis. Flipping around the y-axis, well, I think you would probably guess that if flipping over the x-axis keeps the x values the same, flipping over the y-axis should keep the y values the same. That stands to reason, right? And so if you notice the x and y, the x is changing, the y is staying the same. And so we're going to actually show how that works. So we're going to go over here, same triangle. Let's switch back to my other colors. And if you want to use colors, that's fine. -1, 2, that's my A. B is at -3, 2. It's my B, -3, 5. That's my C. I should be using my straight edge. And there is my triangle. I'm going to reflect it only this time, and I'm going to take my pencil, and I'm just making a strong reminder that whatever it tells you, if it tells you on the assignment when you're doing the classwork to flip on the x-axis, I want you to darken with pencil the x-axis. If it says reflect around the y, you should be darkening, a little bit darkening that y-axis so you can see it there. Okay, now I'm going to reflect according to my line of reflection. So I'm flipping about this line. So to get exactly on the other side, I went one distance from the left of the line here. I'm going to go one distance to the left of the line here. And I got rid of some of those lines, so I got to be careful. And this is A prime. B is located 1, 2, 3 to the left. So I'm going to go 1, 2, 3 to the right. 1, 2, 3 to the right. And that'll be B prime. C, if you notice, is 1, 2, 3 to the left of the line of reflection. 1, 2, 3 to the line of the reflection. Okay. And then I'm going to play connect the dots. So this is going to look slightly different than my last drawing did. And I'm reflecting along the y-axis this time instead of the x-axis. So just a reminder, the C's are traveling the same distance from that line of reflection, the A and the B. Same thing happened here. A is flipping the same distance, B is flipping the same distance, C is flipping the same distance. So what should change here is not the Y. So the Y should stay a 2 here, the B should stay a 2 on the Y here, and then this should stay a 5. The only thing that should be changing is this -1, -3, -3 should be switching to the opposite. So instead of being a -1 here, it's at a +1. And B, instead of being at a -3, it's at a +3, and it's over. So we're going from quadrant, and I don't know if you remember your quadrants, 1, 2, 3, and 4, but I'm reflecting, so I'm going from quadrant 2 to quadrant 1. So these points are all located in quadrant 2. These points, as you can tell, are all going to be located in quadrant 1. So that's another way to check yourself. I know that this is always going to be my positive quadrant. This will always be my negative positive quadrant. This down here will always be my negative quadrant, and this will always be my positive negative. And when you're on the STAR test, you can actually put this information on your paper just to remind yourself. But you can tell over here, this reflection was in quadrant 3 here, and 3 should be in the negative points, and it is. And so another way to check yourself. Okay, so that's it is for reflections. A reminder to make sure you know how to write your algebraic representation, and you're going to want to know this by heart. So if the x's stay the same and the y's switch to the opposite, it is a reflection on the x-axis. If the x and y go to a -x where the x changes to opposite and the y stays the same, it's a reflection around the y-axis. So y the same, y-axis flip. X is the same, x-axis flip. Okay, I hope you got that. Keep practicing, and we'll see you on the next video.